Okay, this is more of 9.1. This is number 2. And we want to write an expression for the nth term, a sub n. So this is what we had. So what I did was I looked at my expression. I got my index starts at 0. So, and my terms were 1 plus 1/3 plus 1/9 plus 1 over 27 plus 1 over 4. So I see something going on with 3's here. This looks like 3, and then 3 squared, 3 cubed, 3 to the 4th. And that's relative to n. That doesn't look too bad, except the 0 here is going to be kind of an issue. So I wrote my n equals 0, 1, 2, 3, 4. So again, this looks like this is 3 to the 1st, 3 to the 2nd, 3 to the 3rd, 3 to the 4th, and that's on the bottom. So I could write this as, and the 1 raised to any power is going to be 1, so that's all right. So I could write this as 1/3 to the 1st, 1/3 squared. See, 1/3 to the 3rd is 1 over 27, 1/3 to the 4th is 1 over 81. But what do I do with this? Well, n is going to start at 0, so I can make my exponent 0. And then my n's match, you see, so this is 0. So you can actually see that this is n. That's n. That's n. And that's n. I could pretty much put anything here I want to put, but what I'll do just to make it consistent, I'll just write it 1/3. Will that generate my series? 1/3 of the 0 is 1, 1/3 of the 1st is 1/3, 1/3 squared is 1/9. So I've got it. So that's my nth term. Now a lot of it's trial and error. You got to try these things. So when I write these things up, it's just to save time. You know, I've kind of had to think about them. Okay, let's take a look at letter B. This is what we got. Now my index is 1, so I got 1, negative 1/2 plus 1/3 minus 1/4 plus 1/5. I wrote my n here, and you can see how the denominators are just n. The only thing is we have this negative, positive alternating series situation. In other words, this is an alternating series. So the easiest way to generate that is just a -1 to the n minus 1, as we saw in the first problem. -1 to the n minus 1. There's other ways to do this, but this is the probably more popular way. It's a little more basic. And you could just check this when n is 1. 1 minus 1 is 0. Anything to the 0 power is 1. When n is 2, 2 minus 1 is 1, so -1, that's a negative. So this is going to generate my negative sign, so this is all I needed, and then my n is in the bottom. So it's pretty much straightforward. Got a little crooked there, sorry, okay? So again, the only difference here, this is 1 over n, 1 over n, 1 over n, 1 over n, 1 over n. We just have to get, so the n is in the bottom, we just have to take care of the alternating sides. Okay? Okay, then letter C. This looks kind of interesting. A to the n, and then I got 5.5, 0.05, 0.005, 0.005, and I put my index is 0, so I got 0, 1, 2, 3, 4. So I notice it looks like I've got some fractions here, so I wrote these as decimal fractions. So I've got 5, and then this is 5/10, 5 100ths, 5 1,000ths, and 5 10,000ths. And I notice here I've got n is 4, and I got 4 zeros. N is 3, I got 3 zeros. N is 2, I got 2 zeros. N is 1, I got 1 zero. A lot of this is inductive reasoning. In other words, it's by observation. You'll see these patterns, and you go, wait a minute, that looks pretty good. So what I do is I wrote it as powers. 5 times 10 to the 0, 5, 10, 10. This is -1. And then if I put this up on top, this is 10 to the -2, 10 to the -3, 10 to the -4. And I kind of realized, well, that was kind of a wasted step because my n's are going to be not -1, but +1. So I had to put them back on the bottom. I should have gone right from here to here and not done this step. But that's part of the process. You try these things until you find something that works. Okay? And this works out. So this looks like this is n is 0. So there's my n, there's my n, there's my n, there's my n, there's my n. I actually could put those in the same color. So there's my n. N is 1. N is 2. N is 3. N is 4. Plus. So it looks like it's 5 over 10 to the n. Okay? So you just have to experiment with these, and hopefully you won't have a brain glitch. Otherwise you can get stuck and then you can't figure them out. So it's a lot of inductive reasoning. Okay, hope that helps.